Hi, I'm Franton,
And I'm Shane.
and this is our SIGSIS final project at Olin College of Engineering.
Here we're trying to transfer data over sound between computers.
So the basic idea is that a first user comes up to the first device and inputs a message. So in this case, hello world. That message is then encoded into binary, as seen here, and we generate a waveform that device can then play through its speakers. We then have a second device streaming this audio in through its microphone, and we get that same waveform back out, which we then do some decoding and analysis on, which gives us the original binary, which we can then decode into the original message.
Going into more detail on the encoding, we are using a 1500 Hz wave to represent a 0 and a 2000 Hz wave to represent a 1. Here you can see an A encoded in binary.
As the second device streams in the wave from the first device, we run an FFT over the audio signal, which allows us to pick out whether or not a 1 or 0 is being transmitted, depending on the 1500 Hz or the 2000 Hz signal. Here you can see our FFT graphs of 1500 and 2000 Hz. We then use this FFT to analyze the wave and determine when we change between our two tones of 1500 and 2000 Hz. So here you can see we detect changes at 0, 125, 375, and so on, and we mark down these times and append them to an array that we're storing. Finally, we take that array of stored times and find the difference between each value at each index. Those differences will show how long each tone was held, and then we can use our bit length to find how many bits are in each of those lengths, and then we can decode the binary from there to get our original message.
One thing we have to keep in mind while taking the FFT is the trade-off between the frequency accuracy and the timing accuracy, which is affected by the FFT buffer length. Using a longer buffer gives us more data points to work with, increasing our accuracy in the frequency domain. However, a longer buffer also takes longer to compute, which decreases our accuracy in the time domain. Optimal buffer size balances our frequency and timing accuracy.
After a lot of playing around with our FFT buffer size and testing out different bit rates, we were able to get a pretty reliable version of our project working. Here's a quick demonstration of our project fully functioning from the view of the transmitting device at the beginning and then the receiving device at the end.
These tones are received by the second device, which are decoded into binary, which then are translated back into ASCII.